Hi, good afternoon. I'm Maheshkumar. I'm a cloud architect at HPE. So I work on the Elion Career Guide platform, which is the Vim layer in the NFV software stack or the NFV solution stack. And my work with the HCG is predominantly on the scale and performance testing. So what we really do is we set up the scale lab in our own infrastructure and then run various scale tests using tools like Rally and collectl and kind of gather all those performance metrics for various different operations like the VM lifecycle operations and other operations, and also the corresponding utilization metrics from the collectl tool, right? And usually during our scale and performance tests, we kind of generate reports, or Rally itself gives you a lot of good data about all the operations that you wanted to run in an iteration, measuring the operation times and other good stuff, right? But the program sometimes comes back to you asking very specific or correlative questions like, okay, now this is the cloud platform and you got so much of performance, but how do you really compare it against the performance that you got in the previous cloud release? Or how do you perform against the competition itself, right? And sometimes there are very specific analytical questions from the program, like what is the memory utilization trend of the Neutron L3 agent when you scale to n different Neutron ports using CVR or the DVR? And what is really the I/O utilization of on the compute node for the VM boot during scale with a Windows image versus Linux image? Sometimes they also ask you compare your cinder-volume performance against different cinder backends when you scale to like 1,000 or 2,000 volumes. And how's really the cloud controller's CPU utilization when for the Nova boot on a scale of 1,000 VMs or 10,000 VMs with computes having different cluster speeds, right? Now, so normally, how do we answer them is we go through all the different reports that the Rally generates and also go and grab all those CSV files that has a utilization data there and sit and try to do a manual correlation and try and mash up these two data and say, yeah, this is how the CPU, memory, and the I/O utilizations were on the controllers when you did the scale of 1,000 or 10,000 VMs, right? But we all know that manual cannot scale. So when you are doing multiple scale runs during a release and generating a lot of data, right, you can't obviously afford to go and get all the data and then mash it up and produce meaningful correlative analysis, right? So there is clearly a need for a tool or a platform to bring all these data together to be able to do a meaningful correlative analysis, right? And also, there is a need for you to run your scale test and the performance test in a much more controlled fashion, controlling all the environment variables, right? Making sure that you just adjust that one parameter in your environment to be able to do some comparative analysis. And also there is a need for this tool to be able to accommodate databases from different sources, centralize them, and give you good options to clean up the source data, extract the fields that you want from those data sources, transform those data sources, and also analyze them, right? So here is one of the tips that I have to offer you today, Talend. So Talend is an open source ETL tool, right? It's a tool that can be used for extracting data from different data sources, transforming them, and also analyzing them, right? It's very simple and easy to use. You don't have to have any programming knowledge to use this tool, right? Even though in the background it uses Java, you don't have to know Java to be able to do the correlations and to be able to do your analysis, right? And this also enables you to do the on-demand scale and performance analytics, right? What is really on-demand is, as I was discussing earlier, we do run a scale test over multiple builds in a given release and collect a lot of data, right? And forget about it. And we don't really push it to a centralized data for correlation. So what this tool can enable you to do is allow you to import data from multiple data sources and then save it in a centralized repository. And whenever you want to run a multidimensional query, you can do it on demand against that central repository, right? And this tool also has got very good support on the web. So wherever you get stuck, you just query for whatever questions that you have, and you get answers there. Here is a picture of the tool itself. I've just captured it at a very high level. It may not be clearly visible, but I'll just talk about it. What you see up there is a simple workflow, right, that I have put there, which basically extracts information or extracts the fields from the JSON files. Rally often gives you scale data output in the JSON format, and this workflow is a flow that shows where you can, import that JSON and then extract the fields out of the JSON and then push it to a table, right? This is just a simple flow showing that. And on your right, you see a palette, right, which has a lot of useful components that you can just simply drag and drop in your workflow and do whatever you want, right? For example, you could do a simple join using a t-join component up there. You could use tmap function. These are basically some of the functions that you use in the analysis world, that if you want to join two tables and run a query, you do that. So all other beautiful components are available on your right. So all you have to do is drag and drop, stitch them in a meaningful way that is useful to you, and run it like a job. You can schedule it, and it does the work for you. All you have to give it to this workflow is your input data that you collect from multiple scale runs, right? So the next slide, I'm going to show you a simple correlative analysis of a simple use case using the Talend, right? So here, I wanted to measure the CPU memory and the I/O utilization for the Nova boot operation, right? So Nova boot operation of a Windows image against a Linux image, right? So I ran the Ubuntu image or Nova boot of the Ubuntu image on a KVM hypervisor, and you got that KVM ubuntu.json, which has a dump of all the Nova boot duration times and the timestamps and so on, right? And similarly, I took the same Ubuntu image, ran it on the ESX hypervisor, and got that ESX ubuntu.json. Similarly, I did that for the Windows image as well. Now, these are the different JSON files that I can dump from the Rally, right? And this has got all your results in it. So on the other side, when I initiated the scale run, my collectl was also collecting the utilization data of the controllers. And what you're seeing there is the utilization data that is collected on my first controller. So my cloud was deployed with 3 different controllers, and these are dumps of the CSV files that collectl gives you on the first controller. Right now, I have 2 different data sources. One is in the JSON, another one is the CSV. So as I discussed in the previous slide, all you have to do is use that logic up here, input, drag and drop this T file, input JSON from the components in the Talend D, and then use the extract JSON fields to extract the Nova boot server operation, its duration, and the timestamp, and make that first table ready. Now, on the other side, point to the CSV files, use the T file input delimited component in the Talend D tool, and then extract all the utilization data. Of course, the collectl does collection of all these data every second. So you just take the first column as a timestamp and your metrics as the other columns, and prepare your second table. Now you have the two tables, and what you can do next, what I've done is used another component called the tjoin to join these two tables and produce this final output here. That tells me this is the Nova boot Nova boot duration for a Windows image or an Ubuntu and an Ubuntu image on two different hypervisors. Of course, this is just sample data. Don't go by whatever is up there. But this is how you can correlate and then produce meaningful insights that can be very useful for your analysis. Also, you can run various other complex queries using this tool. What I've just shown you is a sample. So you can run multi-dimensional complex queries to identify the bottleneck in the scale or the performance, and probably drill down and find out the real reasons. Another suggestion is you could also load up your Monasca DB as another data source, and then join all of them and filter the information that you want based on the timestamps, which will give you even more deeper insights. And Monasca is capable of measuring all those slow queries against different service DBs, and it has multiple other useful data that you can correlate and extract meaning out of, right? So here are some of the references I've got for the Talend D. It's really simple to use, and these references will tell you how to perform a simple lookup operation using the tool, how to do a simple tjoin operation, and a tmap operation using the tool. Right? I hope it is useful. That's all I've got. Thank you.